Okay, the next thing we want to look at is this grain boundary pair highlighting function. So I'm going to open a couple of data sets, but I'm going to start with this copper film demo data set. And if we create an orientation IPF map, you'll see I didn't want to resize it, I'm just trying to move it up here. We're going to go ahead and go to our interactive tab here, and we're going to record data points. And what I want you to see is that as I click, I'm going to just click here, and then I get a little vector that drags across that, and as I click, it tells me with that what's the misorientation between the first point and the second point that I clicked. So in this particular case, it's saying there's a 0.3 degree misorientation about the 878 axis. And this information, again, if we go right click in properties, there's a number of different things that we can show on this. But what we're able to see is that if I click across two different colors, here it's more of a higher angle grain boundary, about an 8 degree rotation. Let's look at, I'm trying to find one that will show something a little higher. This is, you'll see closer to a twin boundary. So a twin boundary is a 60 degree rotation, about a 111 axis. So that's been classified as a sigma 3 CSL twin boundary, very close to the ideal twin relationship, only 0.7 degrees off. Those are pretty common for something like these where we see these parallel bands between those. So you see as we click going across a lot of these, we'll see this material will have a lot of sigma 3 twins. And if we look within a color, it's more of a lower misorientation. And we should be able to find some that are non-twin related. That here, this is not a sigma 3. You can see this, it's classified as a sigma 7, but the deviation is a little bit higher. So it's probably not a true sigma 7 through there. And that's what this interactive tool is able to do. Another good example is I'm going to open a second data set. So I'm going to open one which has, we call it SCC crack, or stress corrosion crack. And here I'm going to create a image quality map, and you're going to see a crack that's present through here. So what we're able to do is, let's just click across a boundary here. Not a boundary, a crack. And if I look at my interactive, you'll see that we can look at what's the misorientation of the crack. What's that crack going through? You'll see this is a crack that's going between grains, an intragranular crack, I believe it'd be called. And sorry if I get quiet as I focus clicking across this, but you get the idea of what I'm trying to do is show what's the path going through this crack. How's the crack propagating through the microstructure? What misorientations is it encountering? And what you're able to see is, again, now I can right click on this and say, let's add this to a project. And let's look at our disorientation plot here. So you can see it's kind of a random plot. Now let's look, instead of the interactive data, let's look at our whole data set. And so what you'll see that jumps out at this, and I will use our tile here so we can compare, is that our regular microstructure is full of these twin boundaries. So again, I have my red color selected. I'm going to just click on this. So if I look at my image quality map, you'll see that this material has lots of twin boundaries present, but the crack really doesn't go through those boundaries. The crack finds a path away from those boundaries. And that's because these twin boundaries are expected to be more resistant to stress corrosion cracking. So people engineer things. They go through something called grain boundary engineering, which is a thermomechanical processing for different materials that's designed to introduce more twins into a material to make it more resistant to cracking. And this ability to be able to go and see which grain boundaries a crack goes through allows us to determine, if this is a true hypothesis or not. And sometimes this goes between grains. Sometimes cracks will go within a grain. And you can go and measure this directly with this type of an interactive highlighting tool with the grain boundary pair tool. Now, the other thing we're able to do, let's go back to a copper film just as an extension of this. In addition to doing a pair, we can also do basically a triple junction. So I can click like here, here, and here. And this basically just extends what we do and says what's the misorientation between point 1 and 2. Here's between 0.2 and 3, and then later on we'll have between 3 and 1 of what's the misorientation. So we can figure out misorientations at a triple junction as an extension of this interactive highlighting option.